When you open your phone, when your laptop boots up, when your tablet springs to life in your hands, something is working in the background quietly, instantly, invisibly. Loads your apps, unlocks your camera, syncs your files, and powers every tap, click, and swipe. It's called the operating system, and without it, your device would be nothing but a lifeless shell. Today, we take it for granted. But operating systems have a long, fascinating history. A story that mirrors the evolution of computing itself. Let's start at the beginning. In the 1940s and early 50s, computers were the size of rooms. Giant humming machines built with vacuum tubes and punch cards. No screens. No keyboards, no icons. Just pure hardware. If you wanted them to perform a task, you didn't open a program. You hardwired the instructions directly. You literally programmed the machine using switches, cables, and punched paper. There was no concept of an operating system. Everything was manual, physical, and painfully slow. But as computers grew more powerful, engineers began to imagine something smarter. A layer of software that could manage the machine for you, organize memory, load programs, schedule tasks, and handle input and output. And so, in the 1950s, the first operating systems were born. They were primitive, built for mainframe computers that filled entire rooms. IBM and General Motors collaborated on one of the first systems, GUIs. It could load and run programs from magnetic tape automatically, one at a time. It wasn't interactive. You submitted a job and waited for the results. No screens, no windows, just paper and blinking lights. But then came a revolutionary idea: time sharing. Instead of letting one person monopolize a machine, why not let multiple users interact with it one after the other in rapid cycles? The operating system would juggle everyone's requests so quickly that it felt like the computer was serving all users at once. This breakthrough led to the creation of Multics in the late 1960s, one of the most influential operating systems ever made. Multics introduced many concepts we still use today: file systems, user permissions, hierarchical directories, and even early ideas about cybersecurity. And from Multics came UNIX. UNIX, developed at Bell Labs in 1969, was simpler, faster, and more elegant. It was designed for programmers, and it became a foundation for many of the operating systems we still use. UNIX didn't have a graphical interface. No icons or buttons, just a black screen and a blinking cursor. You had to type everything: commands, file paths, system calls. But for those who mastered it, UNIX was powerful. It could run on different machines. It was modular. It became the standard for universities, researchers, and eventually businesses. And then, in the 1980s, everything changed again. Computers were getting smaller, cheaper, personal. The PC revolution had begun. Apple launched the Apple II and then the Macintosh, which introduced the graphical user interface to the mainstream. For the first time, everyday users could interact with computers using a mouse, windows, and icons instead of lines of code. Meanwhile, Microsoft released MS-DOS, a text-based OS for early IBM PCs. It was basic, but it worked. Then came Windows. The first version of Windows in 1985 was clunky, a shell that sat on top of MS-DOS. But it hinted at something bigger: a world where anyone could use a computer. In 1995, Microsoft released Windows 95. It was a game changer. The start menu, the taskbar, plug-and-play hardware. It brought together a visual interface with powerful functionality, and it brought personal computing to the masses. At the same time, Apple was building its own OS legacy with macOS later. 2001, it would evolve into macOS, based on Unix principles, but with Apple's signature polish and user-friendliness. And then there was Linux, the open-source wildcard. Born in 1991 as a personal project by Linus Torvalds, Linux grew into a global phenomenon. It was free, flexible, customizable. Linux didn't conquer home desktops, but it quietly became the backbone of the internet. Servers, supercomputers, Android phones, routers, and even smart TVs, all powered by Linux-based systems. Staging of Android, the mobile era brought a new wave of operating systems. In 2007, Apple introduced the iPhone, and with it, iOS. It was sleek, touch-based, and tightly integrated with hardware. It didn't just run apps, it redefined how we interacted with technology. Soon after, Google released Android, a Linux-based OS built for variety. Android could run on phones, tablets, TVs, cars, almost anything. It was open, adaptable, and eventually became the most widely used mobile OS in the world. So operating systems kept evolving. They became faster, smarter, and more invisible. Today, your OS handles more than you can imagine. It manages memory, handles security, connects hardware, syncs across cloud platforms, optimizes performance. All in real time while you browse, scroll, and swipe without a second thought. And now, we're entering a new chapter, intelligent operating systems. AI and machine learning are becoming part of the core experience. Your OS learns your habits, predicts your actions, automates tasks before you even ask. Voice assistants aren't just apps, they're part of the operating system itself. Operating systems are syncing across phones, computers, tablets, watches, TVs, even cars. Everything is becoming part of one seamless digital ecosystem. And yet, through all this innovation, the role of an operating system remains the same: to bridge the gap between you and the machine, to make the complex feel simple, to make the invisible feel natural. From punched cards to neural processors, from black screens and typed commands to multi-touch gestures and virtual assistants. Operating systems have quietly shaped every digital experience we've ever had. They are the silent engines of technology, the unsung minds behind the screen. And as long as we have computers wherever they live, however they evolve, an operating system will be there, humming softly beneath the surface, making it all work.